right, then let's get started. We share the agenda. So welcome, first of all, to this week's Garden Review meeting. We are looking at the 1.147 release and have 6 presentations today. We start with Alexander and 2 new commands in diki related to the config. Then we have Megana with the feature and machine controller for preserving failed machines. Next up, Ismail with the split of the gardenadm discover commands. Then we have Ishan with the change to the daily etcd defragmentation schedule. Then Jeremy with the gardenctl viewer kubeconfig feature via the access level flag. And finally, Oliver with new resource references for extensions and controller deployments. Okay, then Alex, the stage is yours. Please get started.
Okay, thank you. Let me just share my screen. So as mentioned, I'll just show 2 new diki commands in the new release 27.0. So the first one is config validate. With this command, you can validate your diki config. Before the introduction of this command, the validation was done when you execute diki run. Now you can do that before the run. Let me just show how the command is executed with an example. Here I'll use the diki config that we recommend for shoot owners that have, of course, row options for them that is their use, like for example, to group nodes by the worker pool label. Let me just execute the command. Let me just check actually which version of diki we are using. Yes, it is 0.27.0. Let me do diki config validate. It's in example guides. This yeah, so we see that the configuration here is valid. If you had like something invalid, like this label was invalid, this is the label with which we match pods for the row 24.24.14 from this stick. For example, if we have like a dash at the start, if we did validate, we'll get this error that labels cannot start with a dash. Okay, this was for the first command. For the second command, if you go here, so we added support for mergeable rules. Some of the rules we have in diki now can be merged with other rule options. And in the command, we have base and current, where current is with priority. If we have definitions for a row in both base and current, if we can like append them, we would append them. But if it is an option that cannot be appended, current will override base. The base is like the default options. Here in the README, we have more concrete documentation on how this works and the specific command that you can use. For a real life example, as I said, we have this stick diki config that we recommend to users. They can use these rules, these rule options, and if they want to add additional options, additional exceptions, they can of course edit this file, but in the future we might have some changes to it. It could get quite messy to maintain, so it would be best if users have their own current options. For example, this file here, this would be the user provided options, where we have another exception for the row 24.24.14, and we might have some kind of override for another rule. For example, this one, where we have here minimal pod security profile restricted, while in the default one we have baseline. And if we want to merge them, we will again call diki config, this time merge with base. This is the like default configurations, like in example, guides and current, the user provided ones that I showed in example config current, and have output where we want to have the new merged config, let's say in here. Okay, we got it generated. As you can see, it's now generated like for row 2414. Now we have both accepted pods with their labels from the current and the base. And we also have all the other options from both rule sets. And here we have this pod security profile overwritten. Okay, this is what I wanted to show you. Thank you. Any questions?
Currently not. All right. Thanks, Alex. Then we continue with the second topic for today, the machine preservation on failure.
Right. Thanks, Rafael. Hello, everyone. Thanks for having me. Let me just share my screen. Okay. So I will be demonstrating the failed machines preservation feature from MCM and how it integrates with Gardener. So let me take you to the issue first to just set some context. So before this feature, when a machine has issues and these issues persist beyond machine health timeout, then the machine would go to failed and then it will go to terminating. There's no way to recover from there. And this is often not enough time for an operator to investigate what the failures are. So that's where machine preservation changes things. So machine preservation gives operators an option to preserve the machine, or rather retain this machine in the failed phase and keep it there for a configurable period of time. So this preservation can be used in two modes. One is the auto preservation mode and the other is the manual preservation mode. In auto preservation, we basically instruct MCM saying preserve up to so many failed machines as and when they fail. In manual preservation, the operator can specify which machine he wants preserved in case of failure. And preservation can be configured in the per worker pool in the shoot spec under the machine controller manager settings. So auto preserve failed machine max is the field that tells MCM what is the maximum number of machines to be preserved in the failed phase. And machine preserve timeout tells MCM how long this machine should be preserved. Before using the preservation feature though, there are a few things to keep in mind. Preservation is not honored across hibernation or rolling updates. Secondly, preserved failed machines continue to contribute towards the machine deployments replicas. So if you have a preserved failed machine in your machine deployment, it isn't like the MCM bumps the replica count to sort of offset the unavailability. So there is a hit in the availability of the machine deployment. So this should be used judiciously. But if somebody wishes to bypass preservation and get rid of a machine, they can continue to use kubectl delete on the machine or the node object. Now I'll just walk you through the changes in Gardener to integrate machine preservation. One of the key changes is this new shoot constraint, preserved failed machines absent. This is surfaced only when there are preserved failed machines in the cluster. This is to basically draw attention to the fact that the cluster is running with reduced availability. Additionally, so that the shoot can continue to function as usual, especially because these are preserved intentionally in the failed phase. There are certain health checks that are suppressed, such as the operating system config check. And another change is to the shoot conditions, system components healthy and every node ready. So the change in the behavior of these conditions have been made to ensure that there's no noise because of preserved failed machines, and also real issues in the cluster are not hidden or masked by failure messages from preserved failed machines. So system components healthy continues to stay true if the only issues are due to daemon set availability unavailability on the preserved failed machine. And every node ready, the behavior change is that if there are other nodes with issues, non-preserved nodes, then those are surfaced. And if the only issues in the cluster are due to preserved failed machines, then the behavior is as usual. However, there's a suffix added to basically call out that this node is being preserved. Now I'll just I'll show you a small demo. Let me show you the shoot spec first. Okay. So I've got a worker pool here with auto preserve failed machine max set to 1, which means MCM can preserve up to 1 failed machine automatically. And I've got a couple of machines here. Yeah. So what I'm going to do now is to demonstrate how preservation works. I will induce node failure in this machine, which belongs to the worker pool with auto preserve failed machine max set to 1. So what I'm essentially doing with break node is I'm trying to stop the kubelet for long enough so that the machine moves to unknown and then failed. I'm having to do this repeatedly because sometimes the kubelet comes up. So once it moves to unknown and failed, in the regular scenario without preservation, it would quickly move to terminating. Yeah, but now if you can see, fail is persisting and failed here. So let's take a look at the machine. Right. Yeah, so if you look at the current status, preserve expiry time is set to 3 days in the future, 22nd, and it expires on 25th. Additionally, this is a node condition synced to the machine object from the node. It says preserved and preserved by MCM, which means this is the auto preserved case. And MCM also annotates the machine with the auto preserved annotation. Now, if the kubelet hasn't come back yet, I can show you how the machine can potentially recover if the issues have been debugged. Okay, it came back to running. So yeah, this is what happens. So if the issue is resolved, then the machine would come back to running. This transition is new, and earlier there was no way to recover. Yeah, so the machine's expiry time, all of that would have got cleared because it had moved back to running. And the annotation is removed, the auto-preserved annotation that we saw earlier. Now, this is the auto preservation case. Let me show you the manual preservation now. I'll choose a different machine this time. Watch this one, and let's stop the kubelet on this. Before that, I need to annotate. I will annotate this with node.machine.sapcloud.io preserve is equal to when failed, which basically tells MCM if this machine is going to fail, please preserve it. Now let's break this node. The same thing should happen. Machine should go into unknown because the node would have gone to not ready, and then move to failed once the machine health timeout lapses. Yeah, it has moved to unknown and then soon should move to fail. Yep. Okay, this time I will show you how the shoot changes. This may take a little bit of time, but essentially we want to look for the shoot constraint that is added when there are preserved failed machines in the cluster. Let's give this a few seconds. Not gone back to running. Yep. Yeah, here you go. So the shoot constraint has surfaced saying there are preserved failed machines in the cluster, exactly one. Additionally, the system components healthy condition has been modified. So if this modification wasn't done, there would be daemon set pods which are unavailable on this preserved machine, but those have been suppressed. Additionally, since this is the only machine which has an issue, the behavior is the same. The node there is a message that says there is an issue with the node here. Sorry. And additionally, there's a suffix added that this node has an issue, but it has been preserved by MCM. And yeah, it's actually come back to running. So once the shoot updates, the preservation constraint should be removed. Yeah, it's gone away, as you can see. So that was the demo. If anybody wishes to use this feature, there's a usage talk now with Gardener, which walks you through the different annotations and what to expect when a machine is being preserved. Yeah, that's all for me. Thank you. If there are any questions, please let me know.
Cool. Thanks for presenting this. Any feedback from the audience before we continue? If not, then thanks again. And over to Ismail for the gardenadm discover command split.
Okay, you should be able to see my screen now. I would like to introduce the recent changes that we did to the gardenadm discover command. The first one of them was to adapt gardenadm discover to export the backup entry and backup bucket resources and their associated secrets. And the next change that we did was to split the gardenadm discover into two new subcommands, gardenadm discover new and gardenadm existing. Gardenadm discover existing. Yeah, okay, let me give you a little bit context about the gardenadm discover commands. It was initially introduced and designed to support, to make it easy to create a new self-hosted shoot when you already have a existing garden cluster with all the extensions, quad profiles, and credentials created there. So the flow is the following: you build or you prepare a new to be created shoot manifest. But to the gardenadm init command, you have to pass a lot of other resources like the quad profiles, projects, and so on. And you can use the gardenadm discover commands. It will discover all the existing resources from the garden cluster for you. And you can later on pass all these discovered / downloaded manifests to the gardenadm init commands. And in that way, you can create your self-hosted shoot cluster instead of preparing manually all these manifest files. So with the self-hosted shoot clusters disaster recovery topic, we want to also use the gardenadm discover for recovering control plane nodes. That's why the first change we had to adapt the gardenadm discover to also download the backup entry and backup bucket resources and their reference secrets. Yeah, we will need these resources as part of the to be introduced gardenadm restore commands to be able to restore the etcd from the backup bucket. Yeah, I can also mention that to be introduced gardenadm restore command, it will reuse the init flow with some modifications in the flow, and this command will also need the same set of manifests that gardenadm init requires. It will even need the additional manifests like the backup bucket, backup entry, shoot state, and etc. Okay, that was the first change, export the backup bucket and backup entry resources. The second change that we did is to split the command into two new subcommands. We did this, the main reason was separation of concerns, because now gardenadm discover supports two different cases, discovering a new shoot to be created shoot and discovering already existing shoots for disaster recovery purposes. Now you have two subcommands instead of having one subcommand with mutually exclusive flags, because when you want to discover a new shoot, you pass the manifest to it, but when you discover existing shoot, you pass the name and namespace only. And yeah, the better design according to us was to split the command into two new subcommands. Okay, that's all with regards to the motivation/context. With regards to a demo, I prepared the following setup. I created, to save some time, a self-hosted shoot cluster with a single node, single control plane node. I created a kind cluster and set up the Gardener control plane there. And finally, I connected the self-hosted shoot cluster to the Gardener control plane in the local kind cluster. What I wanted to show is how the commands looks like in the previous release and how it looks like in the current release. I have a shoot manifest prepared. This is actually a copy from the self-hosted shoot manifest, which is used in the local step, and the only change I did was to change the name so that this is a new shoot cluster. And if we go back, we can execute these commands against the virtual cluster that I have locally. Okay, it downloaded all the required manifests for the to be created cluster. You can see extensions, code profile projects, and so on. The same command in the new release looks like this. You can see that previously it was discover and the shoot manifest was a positional argument. Now it's discover new and the shoot manifest is being configured via fork. I can run the same commands with gardenadm, the newer gardenadm. The output is similar, and if I diff both of the directories, there should be no diff between them, so they contain the very same output. And the newly introduced functionality, discovering existing shoots. As I said, I have self-hosted shoots cluster connected. I have associated shoot states with it. I have all the backup entries and backup buckets deployed. And the next thing I can do with the discover command is to discover all existing shoots, discover existing, and I specify the name and namespace of the shoot cluster. And you can see that the output is contains more entries here. We have the shoot state, we have the backup bucket, the backup entry, and we have also their secrets, the backup bucket secret. For example, if I diff the new output and the existing output, we can clearly see that we now have this additional manifest exported for existing shoot cluster. I think that's all from my side. Let me know if you have any questions.
Well, Ismail, thank you. Then next up, Ishan with the daily LCD defragmentation schedule change.
Okay, so hi everyone, I'm Ishan from ETCD team. So topic is little bigger. Defrag schedule change comes under this. So little misleading. So yeah, so I'm going to present this PR. Basically, what it does, why it is required. So yeah, you can start. Let me start by giving some background. So last month we upgraded IETCD version from 3.4 to 3.5 upgrade, and after we roll out on our canary landscapes, we observed that DB size based alerts, basically alerts meant for the ETCD total DB size approaching its practical limit, its quota limit increased, the frequency increased, and landscape team DODs have to go and manually defrag the database ETCD. And when they take a look, they observed such pattern. Okay, I cannot. And they observe such pattern basically, as you can see, in after the 6th of June, the DB size was quite stable, like predictable, you can say, but after this, it is showing some weird pattern. And they basically saw very same thing in a web in many seeds of etcds. Like here, you can see that average total DB size is around 1.6, but after the upgrade, after the 6th of 9th of June, average increases to 2.4, and they saw the very similar pattern everywhere. So we take a look. To do the RCA, we use these two matrices. One is total DB size, which is the same matrix as these, shows the total DB size, which basically tells you the total physical size of bold DB file, and another is total in use total size, so which basically only consider only considering the page size of which contains the data. So if I show you the bold DB page allocation, I'm not going into the details, but let's say this red pages are data pages and these free pages, these green pages are free pages, and sequence wise there can be a lot of fragmentation in bold DB file. So if you consider the whole, every red pages and plus green pages, the data pages plus free pages, this makes the total DB size. If we exclude the free pages, then it becomes total DB size in use. So yeah, we use these two matrices, total DB size plus total DB size in use. And if you subtract these two, you will get the amount of data you can reclaim by doing the defragmentation. Basically, whatever the fragmented space available, you can claim it. So we, as I mentioned, we use these two matrices. As you can see, this is a line where we upgraded our etcd. And this dark blue is the in use, total DB size in use, and this light greenish, light bluish line is basically the total DB size. And as you can see, the before the upgrade, the difference between total DB size and total DB size in use was very less, not much. But after the upgrade, the difference has been increased. So it means it require more defragmentation and more to reclaim these pages and all. But the another finding is the total DB size in use is very similar. It is not behaving abnormally. It is behaving same way after the upgrade as well as before the upgrade. But total DB size in use is not behaving correctly. So this is our findings. And so what actually was happening is, so this is the bold DB file, resume. When a data comes, bold DB maintain a list of free pages. When a data comes, it find out, okay, I have the free pages available. It write it down into these free pages available instead of allocating more page. But what our theory was, what is happening is that although the free pages are available, few pages are being used, but not every free pages are being used, and it is end up allocating more pages. Hence, the total DB size in use is not changing, but total DB size is increasing, because you see this blue page is allocating one more page, although it has the free page available. And to prove this argument, that like we have the data, like you can see in this as well, although the total DB size is almost stable or even decreasing, but still the total DB size is going up. So we were thinking that something is wrong with the storage engine of bold DB. So I will just give you some what is happening. So basically, to maintain the list of free pages, bold DB uses our underlying data structure. basically a page ID, list of page IDs in the array. And whenever a new request comes, it just scans the array. Okay, whenever the free page is available, it allocate accordingly. And so long back, the Ali Cloud team did some benchmarking test and all. And once they go beyond 40 gigs, they find out the etcd is not behaving correctly, and their disk sync duration spike and all. And to fix it, they find out that it is happening because of the free list implementation of BoldDB, which is using underlying data structure as array. And to fix it, they introduce a new concept of free list implementation, which is based on a hash map. Array was persisting on the disk. Hash map was not persisting on the disk. It is in memory. So by doing this, they end up improving the write performance. And this is their claim, that they improve the performance. And this PR is basically they have changed the default value of something known as bold free list type from array to map. And this is the PR long back, and this is the commit hash. Remember it. I will show you the proof. So they changes the underlying data structure. So, and our point was, what is happening is, as I mentioned, maybe the map is losing some free pages available. It's end up allocating more pages instead of using already free pages available. And we were reproducing it. My teammate Rinish got success in the reproducing it. So as I mentioned, just remember the commit. So this is a commit where the default value changes, and this is the commit just before it where the default value was array. So he downloaded our seed snapshot backups and run on to these commits, and you can see the total DB size is start diverging in this blue line. You can see this is the commit for that where the default value changes to map. But although the same thing, the in use is behaving correctly. So this proves our theory of okay, this is happening, and I have raised this in upstream as well. Like the claim of hash map improving the performance, maybe it is applicable for the large databases of 40 gigs, 50 gigs. But if etcd is recommending that the quota size is limited to the 8 gigs, then may not be it is applicable. And we have seen the performance degradation in total DB size. So we decided to override this value uh, uh, by exposing it via etcd resource API, and we have overridden it back to the array. But so why overriding? Because we also wants to evaluate between array and map when we increase our DB size to, let's say, more than 30 and 40 in future maybe. So we will evaluate this, but for now, because we are using the quota size of 8, we have override this value back to the array. And result is this result after overriding this value. So you can see this purple is 3.4, quite stable DB size. 3.5, again the same weird pattern. If I remove this, and this is 3.5 with backend free list set to array is again stable. So yeah, this is our finding, and we will not bury this topic. We are taking up this to the community as well. Like this is our observation and all. Yeah, so this is our findings, and the defragmentation. I will just mention it. So we changed that schedule of the defragmentation as well. I am not, maybe I'm over time. But so we have changed the schedule of the defragmentation as well, because as I mentioned, you need quite frequent defragmentation. The initially defragmentation was happening once in a 3 day. So we have changed it to once in a day because it was done when we were non-HA. Gardener was non-HA. Hence, the defragmentation was causing downtime and all. So we introduce, and because now we are HA, we are doing in a rolling fashion, so we can afford once in a day. But there were some concern, like what if the defragmentation is not beneficial? So in the next release, we will have a one validation check, trigger the defragmentation once if it is beneficial only. So let's, as I mentioned about this claim, we will check the free space available. If the free space available is crosses some threshold, let's say 1 GB, 500 MB, then only trigger the defragmentation, else don't trigger the defragmentation. Yeah, these are my updates. Any questions?
Yeah, I have a question, Oliver here, regarding the defragmentation. Is it somehow planned to do a automated defragmentation based on the usage here of the on the file size? So if it's approaching its practical limit, then it's starting an automated defragmentation. If it's an HA etcd, that we can get rid of the manual defragmentation somehow.
So it has pros and cons. So it is in a pipeline. So I think it is planned for Q4. Our teammate Anvesh will be working on the DB size with defragmentation. So we will have some watch mechanism on which we will check the DB size when it will be cross some threshold, let's say 6 GB or 7 GB or 70%, 80% of its quota, we will trigger the defragmentation. But it has pros and cons. So like if there's a rogue controller and because of that it is increasing the DB size, it is not because of our issue, it's some user's issue and they have written some bad controller. Like one issue I remember, the Kubernetes issue. And if we automate everything, then we end up defragmentation again and again, and we will not able to find that it was the user's issue. So we will consider everything, like let's say we will trigger this DB size with defragmentation couple of times. If it is also crossing some count within some window, then we will again say that it is not looks like our issue, it's more like a controller issue, because the DB size is again increasing and again. So we will also improve the Grafana dashboard, which will shows the churn rate as well. So these things will maybe help in debugging.
Thank you.
Thanks.
Okay, cool. Thanks for Ishan. Also, thanks for the question. And let's continue with the next topic. Jeremy and the gardenctl viewer kubeconfig.
Okay, thank you. So good morning. I'll just directly start to share. You should see my screen. My topic is still one that's a follow-up from the last hackathon. There was a lot of constructive back and forth on the feature and on things like scoping and how the feature should be implemented. So the main motivation behind this is currently gardenctl gives you, if you target environments, always kubeconfig that gives you the maximum rights you're able to get. So if you already are assigned maximum admin rights, you will always get those for environments. So if you are an operator and work on productive environments, you always get your productive configs when you target prod environments. And so let's say you have a bad day and you have 1 second where you don't, you're not so careful and do an operation that wasn't supposed to happen, then that's a bad thing. So what this feature is add an option where you can per environment set defaults, where you say, I want for this environment to get viewer access for shoots or for seeds to to not have certain things happen, and only when I want to explicitly get admin access. So to avoid certain accidents, and also maybe for auditing purposes, only start with the rights I need until I elevate rights when I need them to. So that's basically my PR here. There is a new documentation I added that I will post in the chat afterwards. The main point you need to know is basically it's using a garden login underneath. So the whole magic about how it's mapping to RBAC is not happening in gardenctl. The whole admin viewer auto mode thing is from garden login. Previously, it was using auto, and now you can explicitly set admin and viewer. So what's new is basically you can, in your gardenctl config, set in your garden this kubeconfig access levels defaults for shoots and seeds, which you can also set via CLI gardenctl config set garden. And this is basically the default for your environment. And you can also use run-off overrides where you say, okay, the default for your shoots is viewer, but now I want to do some operation which would require admin. And I would then add the admin flag to target, and then I would get admin permissions, overwriting the defaults. So that's it for the introduction. Let's start with a quick demo. The first thing you would do is you have an environment. Here I have a test environment. You would say, I want to set those values. Current sessions are not affected. So if you want to take that into effect, you would target the stage again. And you would now see in the configuration, those values are set now. Now, if you target your stage, I created a shoot. You would see it's printing access level viewer because that's the default. I don't provide any override flag here. And if you select something that's not auto, it prints explicitly so that you know what's happening. And if in this shoot, I now want to get secrets, you will get an error because the viewer role doesn't let you print secrets. But other things like getting config maps is okay. So this will work. And if you say, okay, I now need this right, this isn't enough, you would just add the admin flag. And again, would say system get secret. And now you can get those. One thing to consider is there is an important point, which is also a part of the documentation, this whole scope resolution thing. So if I now target, for example, shoot this one, you will see I get admin rights. That's because this is a managed seed. So basically the resolution is about what's behind it. So it looks at the effective level. So if you target a managed seed as shoot, what you target behind is the server, which is a seed, and then you will use what you configured for seeds. So you have this scope resolution table. This is something you have to keep in mind. Basically, it's looking at what did you target and those rights you get, basically. It's to avoid getting privilege escalation by doing some sidestepping. What's also important to know is this is using garden login, so you get you can use it for managed seeds and for shoots, But for the garden itself, the virtual garden, and for non-managed seeds, it doesn't work because there you have static credentials. So for non-managed seeds, you have this name login secret in the garden cluster where you can't infer your rights. So there you can't set the level, which is why the command just prints this out if you try to do it. So it tells you it's not a managed seed, you can't do this. Yep. And what you also will see is, like I said, if you do a gardenctl kubeconfig, you will see this exec block, and here you will see the access level viewer. So, like I said, the magic isn't happening in gardenctl, but it's forwarding to garden login. So that's it for the feature. Are there questions? I posted the link into the channel.
Apparently not. All right. Thanks, Jeremy.
Thank you.
Then one final topic for today, presented by Oliver, the resource references in extensions.
Yes. Hey, good morning again. This is me, not asking questions, but presenting a pull request. Yeah, and I like to present you this pull request about referencing secrets and config maps in extension and controller deployment helm values. So you might know that we already support resource references in several Gardener objects, like in a shoot, you can reference a secret, a config map for different purposes. We introduced the same thing for the extensions and the controller deployments. And yeah, the motivation behind this can be found here in this underlying issue created by Tim. So the first three different topics of security, motivation to not store sensitive data like credentials in the values field of the extension, because the extension object is not encrypted in the runtime cluster, for example. We have also things like external management of credentials. So we have a vault or whatever where credentials might be stored, and this is also not ideal when you have to add or you have to update the extension or the controller deployment object when things are changing here, because you need something to change the extension or the controller deployment. The third thing is like credentials rotation. Usually we want to have different functionalities to apply versions and of extensions, and a different functionality for rotating secrets. And when they work on the same object, they might fight each other. So it's better to store credentials in a secret for this matter too. Yes, and that's basically the main thing here about. We introduced two new fields, or one in the extension, which is spec deployment resources, because there is already a spec resources field for a different purpose. And for the controller deployment, we introduced the controller deployment resources field, where you can add the resource references. But yeah, all these things, it's easier to understand when you look at it in example. And yeah, when you use the latest Gardener version, you already use the resource references because we included them into the provider local. It has no practical reason here. It's just for testing or demo purposes. And yeah, let's have a look at the extension object here. That's the runtime cluster. And yeah, you see here, let's start with the resource references first. You see here several resource references. The names always have to fit to the Go templating pattern. So yeah, no minus, no underscore, but just letters and numbers. Yeah, so here in this case, there's a resource ref to a secret. This name, the secret is always in the garden namespace in this case. And the same applies for the config map, which is named log levels here. And again, it has to be stored in the garden namespace. And have a look at the secret or in the config map. Let's do an edit directly. Yeah. The secret defines two keys, admission and extension. And when you look at the extension here, it's like I'm defining the log level field of the admission controller by resources log level data admission. So this field. And for the extension, I'm here in the runtime cluster. I'm using the extension field of the same config map. And so for the extension itself, like the controller deployment later on, I'm using this field too. When you work on this extension object, there's there are admission controls to make the maintenance easier. So if you like to change and add a non-existing resource reference here to your template, it complains. And so for other things, when you do like wrong Go templating, it complains. So it does not get everything, but at least it finds some common patterns you might do wrong here. As I said, when you include invalid characters, it complains. So there are a couple of admission controls here for this case. Okay. Now we want to see how this is working. So we have here the config map, which is changing the log levels, or which is defining the log levels. So when we change a log level here, we expect that the underlying extension is changing. So I'm just changing here the admission log level to info, and here you see the pods of the admission. Let's change it. And as you see, new container is starting. Our new pods are starting. yeah, and we changed the parameter here, CLI parameter for the log level. The same we can do, of course, for the extension part. Now we will expect that the runtime extension is restarting, but also the real extension here on the seed. And you see both extensions of extension pods are rolling and getting the new log level. Another notable thing, when you check all the objects, you might find a reference protection finalizer here. So this is added by the reference controller that you don't delete config maps by accident when they are used in an extension or in a controller deployment. Another notable thing is in order to use the secret or config map for reference, you have to label it like this with gardenercloud/role resource reference. We did it the same way, which is already applied for Helm pull secrets. Those exist in the extension object too. And yeah, to implement it the same way, we also added the label here. Okay, one last thing, or maybe last thing. When you check the virtual garden, I added the reference to the runtime extension, but also to the extension on the seed. And I created the secret in the runtime cluster. So for this extension to work, the secret has to be copied somehow to somewhere. And you see I'm checking the virtual garden here now. And when I check the same config map, I don't find anything, because we have a suffix here for with the extension name. And here you find the copy of the extension of the config map, and this copy only exists if there's a reference to the controller deployment. And to prove that they are somehow linked, I switch this back to debug again and take this. So magic, there's debug. Okay, and the really last thing is I initially mentioned that we introduced the resource reference to extension and controller deployment object. We did not check the controller deployment yet. Let's check this. And yeah, here you find the same Go templating as used in the extension values, and also the resource references. This is done by the extension controller in the Garden operator, but you are also able to create controller deployments manually without the extension object, and use resource references. Of course, in this case, you have to create and update your secrets and your config maps manually too. It's again in the garden namespace of the virtual cluster here, but in this case in the virtual cluster and not in the runtime cluster. And all the other things are the same. So there is this label you have to add, and yeah, I'm somehow missing the the finalizer here. I don't know. Yeah, that seems to be a bug. Okay, yeah, that's it.
Okay, yeah. I think we are already 2 minutes over time. So if you have questions, maybe you can reach out directly or answer or just write into the chat here. Can be answered asynchronously later. Okay, then, yeah, we close today's meeting. Thanks for joining. We meet again next week already because there's a special edition for the Kubernetes 1.36 release. And then in 2 weeks, we continue with the regular review meeting. Thanks for joining. Have a good time. Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.